بسم الله الرحمن الرحيم. أهلا وسهلا بكم في هذا الفيديو الجديد. هذا الفيديو بطريقة البومودورو أدرس معي أما باللغة ولا باللغة العربية لكن باللغة الإنجليزية. Yes, of course I speak English because English is the international language and all people understand what I say. So at the first I want to tell you about the experiment in my lesson. In my job. I'm a chemical student and I learn in chemistry and all thing about chemistry. So at the first I have a report of experiment. The experiment chromatography. What's a chromatography? I read and explain to you. And let's communicate together and learn together for this. And please subscribe and like, comment. You are free under this video. Read and write every day, every time. You learn. Yes. So let's start. A little Quran sound you hear because this sound is a very patient and I think it's good to put on this video. So let's start. The experiment chromatography. What's a chromatography? I read and explain to you. So it says the target of this experiment is introducing the word chromatography and the detachment, some ions mixture, some ions solution, and see what the ions and material of a solution. We don't know. We don't know. We want to understand. So the chromatography is a method to understand what's the material of a solution. So this method this method by paper and calculate the RF. What's the RF? I think it says the continuum. Yes. We will reach to meaning RF. Please wait until now. If you know, please now comment under this video. Thank you so much. So, without any question, the chromatography is a perfect method for detachment material of a solution, and because it has all of science. What all of science? All of science? Oh, I know. All of science. I think it's the science mean all methods complain and make small to one method. I think the chromatography is this. Oh, at the first, I'm not at the laboratory, I'm at the home, at the road, so I can do experiment, just I read it at the theory, not at work. But I promise you the external days, the days will coming, I go to laboratory and do it to you. So please subscribe my channel and wait for that video. Thank you. So let's continue. The chromatography word comes from two Greek words. Number one, chrom, it means color, And graphen, it means drawing plan. Drawing plan? Drawing plan means drawing method, showing you the method for the attachment this, I think. So let's continue. This method have discovered by a Russian botanist named Tassoud. Who is Tassoud? I don't know, please comment this. Please comment who is Tassoud. It's a Russian botanist. I can search the Google, but I prefer comment. Read your comment. I prefer read your comment because I think it's better and it's make communicate with you. Thank you. So this method, the chromatography, have discovered by Russian botanist Tassoud at the 1906. Oh, 1906. Yeah. Ooh. And he, the Tassoud, do experiment for discover this method, and he made a powder, a powder solution with a carbonate calcium powder in the glass, and made a solution of plant pigment like chlorophyll, xanthophyll, and etc. And just run it and flew it. Yeah. He made a solution of the chlorophyll and xanthophyll and flew it to the solution of carbonate calcium powder, and the line of lights discovered on wall, discovered on plume, different colors. Wow. Yeah. It says when he fluid the solution on that solution, carbonate calcium, the different color, different lights of light, different lines of light with different color shows on the clone and wall. Wow. Why this happening? Oh, this experiment, it says this experiment prove it, that chromatography, chrom means color and graphy means drawing plan, it's the plan of color, that you can detachment all materials from solution. Oh, that's a good idea. Yeah. And this method now is a very perfect method for detachment material, and as known by clone chromatography. Yeah, clone chromatography, because the different colors show on clones. I think I learned. It says this method is useful for I thought before read this, I thought the chromatography is useful for colorful solution. For example, solution with copper, solution with irons. I thought. But now it says the chromatography method is also is for uncolorful solution, ions, like all ions that have no color. You can use this method. Oh wow. At 1952, the Nobel gift goes to A.G.P. Martin and R.L.M. Sage for these discoveries. The uncolorful experiment as method is useful. I don't know the A.G.P. Martin. Who is A.G.P. Martin and R.L.M. Sage? Can you say? Can you tell me? A.G.P. Martin and R.L.M. Sage. I don't know him. Please write the comment if you know him. Please continue. Okay, the chromatography method is a physically method for detachment or all material of a solution, and it has two phases. Now in whole we have three phases: the gas, liquid, and solid. But for this experiment we have two phases. We have solid for constant phase and gas for floating phase. And you ask me, what's liquid? Yeah, liquid is between the material, the phase between solid and gas. The liquid can constant and especially floating phase. So for this experiment, we have phase solid gas, solid liquid, liquid gas, or liquid. Yeah, we have this. So the floating phase, because of all different things, all different adjectives that all materials have, we can use it for floating phase. So for attractive or excrete, this phase is dependent to floating, the adjective of that material. For example, for liquid, the sound is very, very, very disgusting. Excuse you. Let's continue. Forget. For depending this floating phase, it depends to excrete or attractive of the bias of material. If a material, if a floating phase you choose has less gravity to constant, you can float very simple. Float it very simple. Just go to it, go to this way, go to that way, and because it's a normal or less gravity. But some material and some floating phase has a very, very heavy gravity, and you can't float it very simple. It's hard to use. So it depends to the material, and it depends to different speed. The what speed is floating very slow, floating very fast. How? It depends to material. So
أسمع بهم وأبصر يوم يأتوننا لكن الظالمون
and
الحسرة إذ قضي الأمر وهم في غفلة وهم لا يؤمنون.
Now I say the paper, the chromatographic paper. And now we choose the experiment liquid, solid liquid. Please tell me between liquid and solid for this experiment, what's the constant? What's the constant and what's the floating mass? Yeah, thank you. The solid is a constant and liquid is a floating. For this experiment, we use a paper, a special paper for chromatography and for floating phase. But although the solid is a constant, but for solution, when we say solution, it's a liquid solvent, not a solid solvent. When we say solution, the liquid is solvent, although is a floating mass. Not happening especially. It's a floating mass, also it's a solvent. So in work, case of solution we made for floating. Case of solution by people, please escape it and just like a drop, like a dot on your paper. Please float it. Please float on the paper. Just one drop of solution and and move the corner of the paper to the center. Yeah? No. Please float a corner of the paper to that constant force. You know the constant force. Flow to constant force and solvent. You know this solvent force and until where? Until the dot not connected to that solvent. Just at the top of the solvent, please flow just a little of the paper to solvent. And then it says, you know the law capillarity. Yeah, it says capillarity is a law that we have a very thin duct. The water goes up. So in this experiment, the water goes up and reach to that drop and solute that drop inside. And now
ورفعناه مكانا عليا أولئك الذين أنعم الله عليهم من النبيين من ذرية آدم وممن حملنا
For survival, different survival of different materials, it goes water very fast or very slow. I don't know. It depends to the material. So when you float the corner of the solution and it's wet, the water goes up in a speed. I don't know. because of the capillary law, and it's go up and solve all the drops inside it. And this happening detachment all materials of solution, and you can see by the color they make. So in this experiment we need water and chloric acid, and especially acetone. Yeah. For this experiment, we need a constant phase and floating phase and same temperature. This is a very important, same temperature. And the RF, and calculate the RF. What's the RF? Is a rate of the flow. Yeah, we reach this meaning now. The RF is a rate of flow. Rate of flow means that water goes up with a different speed. This is a RF, or rate of flow. The formula of RF is distance between the solvation from first divide to solvent from first. This distance solvation from first or solvent from first, and it depends to paper type, solvent, and temperature. So when we want to know the color of that drop, we need some definer, some reagent, chemical definer or reagent that show us the color, and we say, oh, it's yellow, so for example it's nickel. It's blue, so it's iron. It's wrong. For example, just for example, when you directly put the reagent to that solution, to that drop, it change the color to that particular color, so we can see what happens.
وإذا تتلى عليهم آياتنا بينات قال الذين كفروا.
The material we need is chloric acid, dense chloric acid, acetone, ferric chloride, mesulfate, nickel chloride, ammoniac dimethyl, galaxine, and water. And tools, we need the roller, pencil, paper, the chromatography paper, special paper, the beaker, 50 and 500 milliliter volume, the capillary duct, and graduator cylinder in 50 milliliter volume. At this experiment, we want to show Fe3+, Cu2+, Ni2+, and CO2+. It's a 4 material that we want to know, are this material at the solution or not. For finding Fe3+ or iron, when the iron and water connected together, a very special color happens, and we don't need any reagent because it has a verdigris. It has a verdigris and special color. So when this color happen and discovered, we can say, oh, this solution has iron, has ion of iron. and we can see directly. The other method for showing this is a combination ferrocyanide potassium, K4FeCN6, ferrocyanide potassium, yeah, and make sediment, and we can sediment that not a solvent. It's not solved. It's a very unsolved, and make a dark blue color. This for finding Fe or iron. For finding copper or Cu2+, it's make a complex in dark blue with combination of ammoniac, or the other method is a ferrocyanide that makes a color red to brown and with unknown structure. For finding nickel or Ni2+, it's make a complex of a color red with dimethylgallium. It's a reagent, and it's make a light red, or I think it's better to say pink. And the other side is for finding nickel is ferrocyanide, iron ferrocyanide. What's a ferrocyanide? Ferrocyanide is very useful for all of this. Yeah, thank you. And make a complex of light, very light green with unknown structure. And for finding cobalt or CO2+, we have two methods. One is heat the paper by heater and make a color blue, and second is of course it's a ferrocyanide ion. Ferrocyanide ion with it's a ferrocyanide with a sediment. Yeah, with a sediment that have color light green. The plan of this experiment is do it under the hood. I do it and make a video to you. Please wait now. Please subscribe this video. I promise you I do this experiment and put it to you. See this and see what will happen. Now if you like this video, please put the like button. For make a solution, we need a beaker, 50 milliliter, 2 milliliter water, 4 milliliter acid chloric, dense acid chloric, and at the end 19 milliliter acetone. So this solution is made, and we flow it to 500 milliliter and close the beaker, because all gas make and full of the beaker we need. So we need a special color, special paper for this, and with a normal size. And please draw a line in distance between corner of the paper and 2 centimeter with a corner. Draw a line and flow this drop I rate on at the line. Then the solution and the drop is the solution with Fe3 plus, the other drop is Cu2 plus, the other drop is Ni2 plus, the other CO2 plus, and the number 5 is unknown solution. So please make it dry and wait and do it again. Do it again, that experiment. Please flute the corner to this, but before it, please please make shape with that paper to a cylinder, but not connected the corner. Please not connected and connected with a chalk, with a chalk in that corner and this corner. Then the chalk will connect them and make a cylinder and put it in the beaker of that solution. But be careful, the line you draw must at the top of the solution. Again, because of the capillary law, the water and solution goes up, but it takes about 5 to 10 minutes. So put it and go everywhere. So after that you get the paper and draw and calculate what's the distance between each drop and the solution. And please distance the long distance between that last drop at this. And please calculate by millimeter. Yes, at the end we have the distance with the solvent at the first line and distance between solution and the first line. Yeah. At this experiment, we use some reagents like ammoniac or ferrocyanide and everything. I think it's making blue color. What do you think? Please comment under this. And yeah, it's very good. So finish. Yeah. Finish this experiment. I think it's good. I think this experiment is good for every chemical students. Thank you. Please tell me what's your channel for looking your experiment, looking your lessons. If you're a chemical student, if you're a doctor, or everything. Please subscribe my channel and don't forget to like and comment. Everything you are free to comment. Thank you so much. Thank you so much from all people see this video. Have a good time. مع السلامة. Until another video in my channel. This is start time. Goodbye.